In the early decades of commercial aviation, airlines treated airplanes almost like disposable technology. Aircraft were replaced rapidly. A new jet promised lower fuel costs, better reliability, higher passenger capacity, prestige. By the 1960s and 70s, aviation had become a symbol of modern progress. Jets evolved quickly. Every generation brought dramatic changes. The Boeing 707 transformed long-distance travel. Then came the 727, the 737, the 747, each one more efficient than the last. Airlines competed aggressively to modernize fleets because fuel efficiency and reliability created massive financial advantages. An older aircraft quickly became economically obsolete. But over time, something changed. Modern aviation stopped evolving rapidly, and aircraft stopped becoming easy to replace. Today, many aircraft families have remained in service for decades with only incremental upgrades. The Boeing 737 first entered service in 1968, yet updated versions still dominate skies worldwide. The Airbus A320 family traces its roots back to the 1980s. Even many new aircraft are deeply connected to older engineering platforms, because designing an entirely new aircraft has become one of the most expensive industrial challenges on Earth. A modern passenger aircraft is one of the most complicated machines humanity has ever created. Millions of individual parts, thousands of suppliers, advanced software, composite materials, global logistics chains, and certification requirements so strict, a single design flaw can ground fleets worldwide. Developing a new aircraft program now costs tens of billions of dollars. The Boeing 787 Dreamliner program reportedly exceeded $30 billion in development costs. The Airbus A380 became one of the most expensive aviation projects in history. And even after spending those billions, success is never guaranteed. Then came the disasters that changed the aviation industry forever. The Boeing 737 MAX crashes. 2 catastrophic accidents. Hundreds dead. Global groundings. Investigations. Public outrage. The crisis exposed something deeper. The modern aviation industry had become trapped between competition, cost-cutting, and impossible production pressure. And suddenly airlines lost confidence in rapid fleet replacement. But the real crisis wasn't just aircraft manufacturing. It was engines. Modern jet engines are miracles of engineering. They operate at temperatures hotter than lava. They spin thousands of times per minute. And tiny efficiency gains save airlines billions in fuel costs. But newer engines also became dramatically more complex. And complexity creates risk. In recent years, engine reliability problems began spreading across the industry. Manufacturing defects, premature wear, inspection backlogs, parts shortages, entire fleets grounded waiting for repairs. Some airlines suddenly realized something alarming. Their older aircraft were more dependable than the newer ones replacing them. Older engines burned more fuel, but many were mechanically proven after decades of operation. Airlines began delaying retirements, keeping aging aircraft flying longer than planned. Not because old planes were ideal, but because replacements weren't available. Then came the pandemic. Air travel collapsed almost overnight. Airlines hemorrhaged billions. Manufacturers slowed production. Workers left the industry. Suppliers shut down. And when travel demand suddenly returned, the aviation system could no longer keep up. Aircraft deliveries slowed dramatically. Parts became scarce. Even basic components faced delays measured in months. The entire aviation industry discovered how fragile global manufacturing had become. A modern aircraft depends on thousands of suppliers spread across multiple continents. If one supplier fails, production stalls. If one chip is unavailable, deliveries stop. If one engine component fails inspection, entire fleets wait on the ground. And suddenly airlines faced a brutal reality. There were not enough new aircraft to replace old ones. So they extended the lives of aging fleets instead. To passengers, old airplanes sound dangerous. But in aviation, age alone does not determine safety. Maintenance does. A properly maintained aircraft can operate safely for decades. In fact, many older aircraft remain structurally sound long after their expected service lives. The problem is economic. Older aircraft become increasingly expensive to maintain. Fuel costs rise. Parts become harder to source. Inspections become more frequent. Downtime increases. And eventually airlines reach a financial tipping point. But recently, another calculation changed everything. New airplanes became so expensive and so difficult to obtain that keeping older planes flying became financially preferable, even with higher maintenance costs. Major airlines now face years-long waits for new aircraft deliveries. Some carriers won't receive full orders until the 2030s. That delay fundamentally changes airline strategy. Aircraft once expected to retire at 20 years old are now being pushed toward 30, sometimes beyond. But keeping old planes alive requires something increasingly rare: experienced mechanics. And across the aviation industry, those workers are disappearing. Thousands of skilled technicians retired during the pandemic. Many never returned. Meanwhile, younger workers entered other industries offering better pay, lower stress, predictable schedules. The result? A growing maintenance labor crisis. Modern aviation now faces a paradox. Aircraft are aging. Maintenance needs are increasing. But the skilled workforce required to sustain them is shrinking. This creates mounting pressure throughout the system. Longer repair times. Delayed inspections. Maintenance backlogs. Higher operational risks. And more pressure on the remaining workers keeping fleets operational. In deserts across the American Southwest, thousands of aircraft sit in storage. Some wait for scrap. Others wait for revival. These aircraft graveyards became strategic reserves for the aviation industry. As parts shortages worsened, airlines began harvesting components from retired planes to keep active fleets alive. Engines, landing gear, flight computers, hydraulic systems. Entire aircraft became donor machines. This practice is legal, common, and increasingly necessary. But it also reveals something deeper. The aviation industry is no longer operating with comfortable industrial surplus. It's improvising, recycling aging hardware to stabilize a strained global fleet. Most passengers never notice. Cabins get renovated, seats replaced, lighting modernized, Wi-Fi installed. An aircraft built in 1998 can appear brand new inside. But beneath the cabin aesthetics, the airframe continues aging. Every takeoff and landing stresses the structure. Every pressurization cycle slowly fatigues the fuselage. Every hour in the sky pushes components closer to maintenance thresholds. And airlines constantly balance three competing realities: safety, profitability, and fleet availability. Aviation remains one of the safest forms of transportation ever created. But maintaining that safety depends on relentless inspection, regulation, and maintenance discipline. The danger is not simply old airplanes. The danger is what happens when industrial systems become overstretched. The aviation industry now faces a future filled with contradictions. Passenger demand continues rising globally, but manufacturing capacity remains constrained. New aircraft programs grow more expensive. Supply chains remain fragile. Workforce shortages continue spreading. And environmental pressure is forcing airlines toward expensive technological transitions. Electric aircraft remain limited. Hydrogen aviation remains experimental. Sustainable aviation fuel remains costly. Meanwhile, the global fleet continues aging. The uncomfortable reality is this: the world depends on aviation more than ever. At the exact moment aviation itself is becoming harder to sustain. Not collapsing, but straining. Quietly, systemically, industrially. For decades, modern society assumed technology would always move forward. Faster, cheaper, better. But aviation reveals a more complicated truth. Some systems become so advanced, so global, so expensive, that replacing them becomes extraordinarily difficult. And when replacement slows, Aging systems remain in service longer and longer, not because the future arrived, but because the industrial machine behind the future became harder to maintain. The aircraft crossing the sky tonight are not just machines. They are symbols of an entire global system trying to hold itself together. One inspection at a time. One repair at a time. One delayed replacement at a time. And somewhere above the clouds, millions of passengers continue flying through a system most of them will never fully see. System growing older, while struggling desperately to keep moving forward. Fade to black. The systems you depend on are more fragile than they appear.